Hi friends, Mrs. McBride here. I'm sorry I'm not here today. I'm in Lake Placid for a hockey tournament with Nora. What you're doing today is a little work, get it? A little work, energy on an incline lab. And the purpose of this lab is to study the work done and the energy changes on an incline. Lucky for us, we have this incline here, okay? So everybody should have an incline and also a box of stuff. They're located on the back table back here. Okay, so every setup needs one of these. Now, you can work in table groups or you can kind of divide and conquer, but I only have 6 setups. Now what this setup is, this is called an air track. Okay, it's called an air track because it blows air. So when you go ahead and turn this on, you know what's helpful? If it's plugged in. When you turn this on, okay, what you'll notice is that there's air coming out here. Okay, this is kind of like a triangular air hockey table. The reason why we use this is because it will act kind of like a frictionless surface. So it's not completely frictionless, but it's pretty darn frictionless, and that's why we're going to use this. You should feel the air coming out. We're going to use these carts on here. Now there's a couple of important parts. This cart needs a little flap. If your flap is not very flappy, try to straighten it out or get another index card. You guys are smart. And there's this bumper. The cart itself is about $100, so try not to drop it. Some carts fit better than others on particular air tracks. If yours doesn't slide very well, then just go back, and in the back there, in this box here, there is extra carts. Okay? So if we're thinking about what we're doing for the lab, the first column here says we're going to find the force to drag without air. Okay, so I'm going to turn the air off on the air table, and I'm going to grab my cart, and I'm going to flip it around here, and I'm going to use the spring scale, and I'm going to drag this up, and I'm going to measure what the force is. You can imagine that my force to drag with air would be the same thing, only with air. Now for the distance, make all the distance 1. Now what does this really mean? Okay, well this means that if you're going to go from, do you see how there's this scale here? See the scale in yellow? Okay, some of the scales are in, oh no, I lied, they're all in yellow. Okay, when we're doing our experiment, if you're like, say for example, starting at the 120, okay, that's 120 centimeters, you're going to end at the 20. Okay, that's your 1 meter of distance. The next column here is mass. That's the mass of your cart. This is what we're changing in the lab. Okay, so start by measuring this on the balance back there, and as a reminder, when we're going from grams to kilograms, I'm sure you all know we're going to divide by 1,000. I'm also sure you remember that to find the weight of something, we're going to use that Fg is equal to mg. Okay. Now the last 2 things we need are the height. See in my picture here how it shows kind of the height drop? So what I'm going to do is I'm going to measure with my ruler the height that this is at my 120. My video is not very good. Okay, I'm going to measure the height that this is at my 120. For me, it looks like the 120 is at 20 centimeters. Then I'm going to come down here and measure the height at the 20. That's my 1 meter, right? And it looks like that is at 6 centimeters. So for me, the height, or the change in height, would be 20 minus 6, or 14 centimeters, okay? Or 0.14 meters. So on my particular lab, I'm going to write down that the height is 0.14 meters for every one. Okay? And then last but not least, you're going to find the velocity. Okay, so the velocity we're going to find by using the little speedometer. Okay, you know these wonderful pieces of equipment here. To get this set it on the table, hold the button down, think happy thoughts, and it should go to flashing. If your fingers are somehow in here while you do this, it won't set correctly. If yours is not working, there are some on the back counter, okay? So I'm going to reset this. I don't have a partner, so you are going to do this, but you're going to place this kind of hovering over at the 20, and your partner is going to release the cart from your 120, okay? And you're going to kind of have the speedometer go through the flap so it will measure a speed, okay? And that's what's gonna go on here. But as you remember, this is in kilometers per hour, but I don't want it in kilometers per hour, I want it in meters per second. So remember, whatever you find the velocity to be, you have to multiply by 0.2778 in order to go from kilometers per hour to meters per second. Okay, once you've done the first trial, so the first row, what we're gonna do is change the mass. Now I have these extra masses here. You are going to find some tape and literally tape them on here, okay? Then you're gonna complete all of the steps again with extra mass, then add more mass, then add more mass, then add more mass. Everybody with me? Hopefully yes, okay? Please stop this video and go ahead and start taking your data. And I'm going to make a whole nother video, yeah, that's right, 2 videos for the price of 1, on how we're going to calculate the back part, okay? So you don't have to do the conclusion questions today. I would like to conclude with you. But in my next video, I'm going to talk about how do we do the calculations. Sound like a plan? All right, see you in a few minutes.